Good morning everyone. This is our project based on real-time Python applications, and our project title is Automatic Railway Gate Control System. And this railway gate systems we use in railway crossings, and this application can be used either in national highway crossings and etc.
Project we use two IR sensors. IR sensor is nothing but infrared sensors, and one Arduino UNO, or else we can use a Raspberry Pi, and we use two servo motors to control the position of the gates.
By using this project, we can eliminate the women errors and we avoid the traffic barriers.
Arduino is the brain of this project. We have made programming to the Arduino using Arduino software. As the train is the first proximity sensor, the proximity sensor will sense the arrival of the train, and it will give signals to the Arduino based on pulse width modulation. The Arduino will trigger buzzer first, so that the alarm will get and the travelers will get alerted and go away from the tracks, and then the gates will be closed by the servo motors. As soon as the train reaches the next proximity sensor, the Arduino will sense that the train is came crossing the gates, so the Arduino will give signals to the signal lights. They will show the indication of green light so that passengers can pass the gate and the gates will get opened. So in this way we can reduce the requirement of gatekeeper, and we can, as the system is very fast, we can reduce the traffic.
For the prototype, we are using EEE sensors to upgrade this project with we can use proximity sensor and camera sensors for upgrade results. And in addition to that, we can use GSM module to send the message whenever the gates are not closed. GSM module will send the message to the local pilot. Then he will try to stop the train. Then the accidents will be
includes automatic railway gate closing. This can be done using Arduino. So this can eliminate two errors. We have done this project with the help of our mentor Ramesh sir, EEE department, and HOD ma'am of EEE department. Thanks for providing the opportunity. VNR VJIET.
Hello everyone, we are the students from VNR VJIET EEE department. Today we are going to demonstrate our project titled Contactless Doorbell. Recently, the global pandemic caused by COVID-19 has urged people to create contactless devices so that the further spreading of this disease can be stopped. So, by keeping in view that the doorbell is most frequently used device in every house, which can be effective in spreading the virus, in view of this, we have created a contactless doorbell which does not require any physical contact to make the bell ring.
Components are used are Arduino, ultrasonic sensor, buzzer, LED, 9 volts battery and breadboard.
In this, we select a specific range of distance of an object or hand from the sensor. The ultrasonic sensor detects the distance between the door and our hands. When a person places his hand before the sensor, then the buzzer makes the sound indicating the arrival of someone at the door. Here we have written a code in Arduino IDE and dumped into the Arduino. After the code was dumped into the Arduino, we can give the power supply to the Arduino by using an external battery of 9 volts. And let's see the working of this project. Whenever we put any object before the sensor, then the sensor detects it and the buzzer rings. Whenever we remove the object, the buzzer offs. The applications of this project are we can use at domestic homes, and also we can use for avoiding the transmission of virus such as COVID, etc.
project title is Automatic Solar Tracker. The components we have used are LDRs, solar panel, charging module, battery, boost converter, Arduino and DC servo motor. Generally, in a solar power plant, panels will be in rest position with a tilt of 20 to 40 degrees. In this project, we are going to rotate the panel according to the light intensity. We are using LDRs for sensing the light. A code was dumped into the Arduino for this operation. When maximum light intensity hits the panel, LDR senses the light and there will be variation in resistance. And due to this variation in resistance, there will be change in the current and accordingly motor rotates. That motor rotates the panel such that it follows the sun movement. Whenever LDR stops sensing the light, panel comes to the initial position. Instead of using these sensors, we can change the code such that the panel and sun moves parallelly according to the time. By doing this, we can increase the power production by 25 to 30%, including the losses due to motor. Thank you.
We are here to present a project called Smart Dustbin. The main objective of our project is to keep our surroundings and environmental clean. And we have inspired this project from Swachh Bharat Mission. The components we are used are Arduino Uno, 9 volts battery, servo motor, ultrasonic sensor, jumper wires and dust. Arduino is used for code execution, and its ultrasonic sensor. Ultrasonic sensor senses the objects when it is nearby, and servo motor. Arduino sends signal to the servo motor, and servo motor helps in lifting up of the dustbin. The advantages of the smart dustbin are: the smart dustbin helps to create cleaner, safer, and hygienic environment, less management cost, and the smart dustbin can be seen in more busy places such as airports, railway stations, malls, campuses, etc. The smart dustbin can be used by blind people as well as disabled people. The number of bins needed can be reduced, and using the smart dustbins, the overload of waste can also be reduced.
We are from Electrical and Electronics Engineering branch, and our team members are Shravani, Sriram, Rachna and myself, Praneeth. So basically, title of our project is Respiratory Health Analyzer, and using this kit we will be measuring three main parameters, which are lung capacity using the spirometer, pulse rate using pulse sensor, and temperature and humidity using the humidity sensor. Firstly, we'll have to inhale through this pipe, and depending upon the number of balls that will raise will decide the lung capacity of the person. When the balls will raise, the IR sensors will detect the number of balls that are raising, and then the data will be transmitted to the Arduino, and then the Arduino will process the data and display the particular lung capacity depending upon the number of balls that are raising. And using this pulse sensor, we can see as my pulse rate is showing as 72 or 78 degrees, which is completely normal, and temperature sensor is also showing the temperature and humidity, which is 43, 44 and complete and raising, and the temperature is 33, which is in degrees Celsius, that is a normal human body temperature. To store the data, we need to press this button, and then it will indicate start breathe through light. Then we need to start to inhale through the spirometer. Then if the three balls are raising, it will show 1200 cc. Now to start the kit, initially we need to give power supply. As soon as it turns on, we need to give our hotspot connection to the device so that it will be Wi-Fi ready. Once the kit is Wi-Fi ready, it will show various parameters. As you can see, it will show temperature, humidity and heartbeat. The main reason of introducing this kit is that, as we all know, the chronic respiratory illnesses like asthma and others have an impact on breathing. The third biggest cause of mortality globally is a respiratory disease, which places a heavy load on patients, doctors and healthcare systems. Also, people with asthma have to go through spirometry tests in multi-specialty hospitals wherein the equipment is very complicated and difficult to use. As we can see, there are several steps here to perform a normal spirometry test, and the equipment is really heavy and costly. So, to avoid that, we can use this simple kit, the respiratory health analyzer, where we can do all the operation that is performed by the spirometry test in multi-specialty hospitals, and also additionally we can note down the data of pulse rate and temperature, and also we can collect the data that is retrieved from the device using the Bluetooth module into our web application, which provides all the data and along with date and time, and it can also be viewed in a graphical view of all the separate quantities that are being measured.